Hi, kids. Hey, you should have done the gwhiz lab where you dropped something and then using the graphical app or using, slow-mo video or whatever, you figured out the time that it falls, and then the goal was, hey, I want to find the acceleration due to gravity. Okay. Just so you know, the acceleration due to gravity is sometimes called g. If you've ever heard, hey, you were on a roller coaster and you experienced, 3 Gs, that means you experience 3 times the acceleration due to gravity. Okay. So we're trying to find this lowercase g, or the acceleration due to gravity. All right. So what did you do? So you dropped a ball. So let's draw a picture of that. All right. So here's a ball, and I dropped it, and it went down to like that. Okay. On the way down, if I was to draw an FBD for it, that's the only force acting on it is just gravity. Okay. You did not want to draw a beach ball, because if you draw a beach ball on the way down, you're going to have more than just gravity acting on it. You're going to have air. Now, technically, if you dropped a tennis ball, if you dropped a tennis ball from high enough, there would be air, like air resistance is going to be significant. But if you're dropping it down steps or something like that, the air resistance is just not that big, okay? Um, if we're doing it when we're doing it at school, we drop golf balls to make sure that air resistance is definitely not going to be a factor. But that's what it's going to look like. And then it's going to fall down. So, hey, look, it is going to be accelerating down because my net force points down, and it's going to be moving down. Well, if it's accelerating down and moving down, what is it doing? Oh, yeah, it's speeding up. So, like, if you were to label where the ball is at different times, it would look something like this. So in equal time intervals, the ball's going to fall further and further and further. Okay, that should make sense. Then you were supposed to find the average velocity. And you'll notice I said velocity, not speed. Average speed is just distance over time. Average velocity is displacement over time. Now, I know we are using x sometimes for displacement. I'm going to use y since we're going to talk about vertical displacement. So it's displacement over time, which means if we are calling this way positive, then your velocity would be positive. You're calling down negative, then your velocity should be negative. I'm going to call it down negative because that's kind of what we do most of the time, but you could do it either way, okay? But you should have gotten this divided by this to find your average velocity. Now, again, our goal is to find acceleration. Well, we know what acceleration is. Remember, I have this really sweet car, and my sweet car goes from 0 to 60 miles per hour. Oh, yeah. You want to know how long does it take to go from 0 to 60 miles per hour? Does it take 10 seconds? Does it take 10 minutes? That's a big difference. So what is the acceleration? The acceleration is the rate your velocity changes. So in equation form, the definition of acceleration is just this: the rate your velocity changes. You'll notice it is not this, the average velocity over time. That is not your acceleration. No. It is the rate your velocity changes. So anytime you do change in anything, just like in your math class, like you find slope, it's change in x, change in y over change in x. You go y2 minus y1, x2 minus x1. Same thing here, okay? That you're going to say change in velocity is going to be, if I say change in velocity over time, that's the final velocity, which most of the time we label it just v, minus the initial velocity, which we're going to be calling it v0 for like the original velocity, over the time. So if you go back to your handy dandy picture, let's label some points. Here's the point I dropped it, and there's the point right before it hits the ground. Well, what do I know right here? Well, I know right here it's 0. Well, this I don't know. So I'm going to have to find that. okay? And I also know from A to B, so if I was to write down, well, what stuff do I know? If I'm going A to B, what stuff do I know? Well, I know my Y. You guys measured your time using the app. I know my initial velocity. I know my I can find my final velocity. Oh yeah, look, just like in your average speed lab. Well, average velocity is y over time, but average velocity is also, you add up two numbers and divide by 2. But do you see how you know this, you know this, you know this? So solve for that. Pretty cool. And then you know this, you know this, you know this. Solve for that. Pretty cool. Okay. Um, well, that would be how mathematically we're going to solve it. Graphically, here's what we're going to do. You guys are solving for the final velocity right before it hits the ground, and then you're going to make a graph. Okay, velocity, meters per second, versus time, seconds. And the only data point you're 100% sure about is that one, because when you first release it, it is not moving, because you're releasing it. You're not throwing it. And then your velocity graph should have looked something like this. Okay, it should have been linear. It should have been in the negative land. Why? Well, assuming we're calling down negative, okay, it should be in the negative land. And then you were supposed to do a couple different things. You were supposed to find that area. And if you're finding that area, well, that would be 1/2, because that's a triangle. 1/2 base. What's my base? Well, my base is this many seconds. So it would be my area would equal 1/2 the time, which is whatever seconds is, and then times this. Okay. Well, what is this times this? Oh, yeah. That is going to be your displacement. Meters per second times seconds. Meters per second times seconds. That goes away, and you're left with meters, so I get my displacement. You'll notice the area is going to be negative. Why is that? Because the ball went down. My displacement was negative. Well, if I find my slope of this, okay, that would be the change in velocity over time. Hey, that's going to be my acceleration. Okay? Hopefully that helps. You should, hopefully the gwhiz lab makes sense. All right, bye kids.